Okay, so I started now the recording. So here, this whole introduction will be in your textbook in chapter 1. It's a very nice chapter. It has just a little bit of history and statistics, and it's easy. It's not hard to read. It's like a few pages. So I want you to start reading chapter 1. On Monday, we're going to have also another Zoom, but I will just highlight what is needed from you guys to do this week in terms of chapter 1 and chapter 2. Most of the things in chapter 1 chapter things that we have already had in your highway design and or transportation class, so it's not a problem at all. It's actually easy. Uh, So let's start, guys. I'm sorry about my phone. Okay. So, uh, so when we talk about transportation engineering, things that we did in our transportation class, if you had my transportation class, then this is just the definition that was done by the ITE. If you remember on Wednesday, I brought the ITE handbook. So it's like our kind of Bible. And it has a definition. If you remember, transportation is when you want to apply some design, scientific technology in the planning and functional design and operation of facilities. And this is your target to provide a safe, rapid, comfortable, convenient, economical, environmentally compatible movement of people and goods. So this is what you want. Let me put it in plain words here. You want to provide something that is safe, and that's your first and main target. Rapid, fast, has some mobility. You want something people to feel comfortable. And also when you want goods to be moved, the word comfortable here maybe is equal to something that comes in time and also comes in one piece, like we say. So it's something that's convenient as well. Cheap. Cheap is an important thing. We want people to be transported from one place to another in a cheap and with minimum negative impacts to the environment. Always transportation, and that's our problem here, is has some diverse effects to the environment. We have transportation facilities occupy about 25% of the land, and we produce emissions, we cause noise. So transportation is always adverse to the environment when you want to move people and you want to move goods. So that's the problem here with transportation. So you want all these 1, 2, 3, 4, 5, 6 objectives to be in line. Sometimes these objectives are contradictory, meaning that sometimes you want something that's rapid. Rapid, you can build 200 lanes, but this will cause problem with economics, so it's not cheap. Also, safe sometimes is also contradictory with rapid. Something that fast might be not very safe. When you can come to your campus driving a car 200 miles per hour and your car will do it, but it's not safe. So some of these objectives contradict. And here it comes you as an engineer, you want to work on this. That's transportation. So we have this in our transportation class. Let's now talk about traffic. Again, the ITE definition. Also, it's going to be the same, but here we have a very specific target here. It's the branch of transportation or civil engineering. That's I'm going to tell you why we do it as civil engineers. Concerned with the safe. Again, the word safe. And that's why, guys, traffic engineering, if you remember the umbrella that we did in our transportation, where transportation was the umbrella and under it different parts. Part of it was traffic engineering. Traffic engineering also, if we put traffic engineering in the umbrella, under it, there's a very important part of traffic engineering. It's very vital. It's a hot topic. People care about it because people die. Something called traffic safety. And if you remember in class, I told you about These guys making really good money because their work is very vital. It touches all our lives because thousands and thousands of people get injured and die every day. I'm going to talk about some little bit of statistics of traffic crashes that happen every single year. And the study we do here in traffic safety is really simple. It's a little bit of data and statistical work, and we give some recommendations to the highway designer and other politicians of what can we do to work on traffic safety. I'm going to talk about this today. So we want safe, efficient, and the word efficiency is another important thing. We don't want to move people and they're stuck in traffic for hours. We want to solve the problem of congestion, movement of people, and goods. Traffic engineering is more concerned now with this guy here, roadways. So we deal side by side. So you as a traffic engineer, you always, even when I used to work in the industry, I used to work side by side with the highway design. The highway designer, like if you guys had the highway design class, we work side by side. We do not overlap our work, or we actually always collaborate together the same work. We do something totally different than they do. They do design of highways, move lanes, so on. We do more of an operational management of traffic. How can we solve traffic problems? We do lots of simulation work. We use lots of computer work, and we deal with their design. Some highway designers, they have to go out to the road and they figure out how does the road look like. Some plans, they deal with lots of drawings, AutoCAD. We deal more lots of analysis and design of these facilities. When I say design here, we're talking about control facilities of the road. So we deal with mainly traffic flow. We sometimes deal with road geometry with the highway designer. And as we move people and other goods or other things, we deal with sidewalks, bike facilities, shared lane, markings, traffic signs, lights, and more. So we deal with everything related to cars on the road to improve safety and reduce congestion. So we have different definitions for traffic engineering. This is the most, you can say, uh, easy definition and not easy, the most comprehensive definition that we use. There's another definition. So it's the one here in your textbook. It's the subset of transportation engineering. The phase of transportation deals with planning. So we do some planning. We do a little bit of geometric design with the help of the highway designer. So we work side by side with the designer. And then comes the thing that you'll be doing completely by yourselves. Traffic operations of roads, streets, highways, networks, terminals, lands, relationships with other modes of transportation. So here we deal with the highway things we have on the road. We have cars. How can we deal with improving that? So I'm going to move now with very, very simple and nice example. One thing that we always care about as traffic engineers is what we call here multimodal transportation system. You might know what does that mean. If you move around Beckley, downtown Beckley, you're going to find next to the police station, the new police station, the Greyhound station, and you're going to find this word here, a multimodal station. It's not a new thing, but it's something that we all care about as transportation and traffic engineers is how can we have a road and a station that is multimodal. In other words, this road, well, probably here in West Virginia, most of the road is just mainly vehicles, cars. But we want our facilities to be multimodal, to give people more choice to choose between two or more different transportation options. So this guy can take a bike, he can walk, and there are all facilities that will help him. There's a bus or maybe a monorail. Monorail is this kind of train that's hanging up. You can see this in New York. or some kind of something in the middle of the road that moves people in a more rapid way, and it's public transportation. So we don't only have vehicles, we have other kinds of transportation modes all work together. And then comes the station, this multimodal station. It's the one that has some kind of combination between different types of transportation modes. It might have a parking lot, so when you can park your car, take the bus or take the Greyhound and go somewhere else. Or you come here by this monorail or the bus, take another bus or take the subway station. You might see this in New York when you go to the Union Station or the Central Station, where you can find trains, buses, subway station. It's all connected into one. This is called a multimodal transportation. Why do we want that? It's part of our work as traffic engineers that we want to reduce congestion. When I always want to give this example, when you have a roadway, and this roadway, let's imagine that each one drives his own car, especially with this pandemic, people care now to not to share anything, including cars. So let's imagine that this road is packed with 20 cars. 20 cars means 20 people. If you had an idea that to increase the car occupancy, we had this word in transportation. Car occupancy is simply how many people you have in the car, from one person to let's say 3 people. Then you're going to reduce this number by 3. So you're going to have only, instead of let's say 21 cars, you're going to have only 7 cars. Let's imagine now that we have more some kind of another really nice rapid bus that would take 40 people. So this can be just, you can have, instead of 21 cars, you can have just one bus that will be. So public transportation is one really good way to reduce congestion on the road and give people more choices in using these transportation facilities for the best. Uh, I've just heard yesterday on the radio something that's really interesting with the COVID-19 outbreak here in the US and all around the world. If you went to Walmart, you probably see that there are no bikes anymore. Bicycles has been a problem. Why? Because some kind of a supply chain problem in Asia. He started talking, when we were talking about this problem, the demand went up. Why did the demand go up? Because people tended to get away from cars and vehicles because of social distancing. They don't want to take Uber or taxis anymore, especially in bigger cities when people do not have cars. Public transportation has become less attractive to people who want to do social distancing. So people started to take bikes or ride street bikes like crazy. And there was a huge demand in the last few months. And here comes us as traffic engineers, that are we designing our roadways with some kind of bike facilities? When I talk here about bike facilities, we do have 2 bike things, something called bike lanes. It's these small lanes of bikes you find on the side of the road, or we can have bike paths. Bike paths are simply just small roads that are connected in a smart way throughout the city. And these are paths that connect. You have bike, and you can find this in Beckley. You're gonna find the bike path just behind this central McDonald's in Beckley. You're gonna find a path specifically for bikes and pedestrians, of course. Part of the traffic engineering work that deals with bikes and peds, we call this active transportation. Active transportation, there are now engineers that are just dealing with that, active transportation. They try to look at how can we provide the best and the most user-friendly facilities for people to walk. I'm not talking here just walking for sports. Walk to work, walk to your bus station, walk anywhere by providing uh, sidewalks, by providing paths for people. If you go to colder areas, for example, when I come from Toronto, so in Toronto, you're going to find a complete city under city. There's what they call it the path, where you can find underground, especially in the winter time, underground paths that are connected to the subway stations, and it connects the whole downtown area in Toronto. So this is something that we all care about, to have user-friendly and good facilities for people. This all together comes to what we call here a multimodal system. Not just build roads and add lanes for vehicles. We want to find different ways to move people and goods from one place to another without congestion and in a safe way. So let's now move to the next part, and we talked about safety. These are some statistics from West Virginia, and our governor has a report or creates a report. This report is updated every single year. It shows what has the state, the DOT, does every single year to provide the best safety for people. It has some statistics from the year before, and you can see here the numbers. The numbers are very staggering. Uh, and this is the number that I care about and you should care about. Into 2020, even though people travel less because of the pandemic, we still have hundreds of people. This is fatalities. Fatalities here, it means people died. And we care as engineers to reduce the number of people dying. Some cities around the world are trying to reach this target of zero fatalities. And some other cities around the world are trying to reach this zero crashes, not even fatalities. They want to stop crashes. Car manufacturers now are trying to find other ways to improve this by adding, you can notice this in your car if it's a new car, that it has some things that help you or some technologies that help you reduce the fatalities and crashes in general. It's safer than the cars we had in the 80s and 70s. We have airbags, we have ABS, we have different things in the car that tries to improve the safety and reduce the crashes. Now we have warning systems, things that would warn you if somebody comes clear in the other lane, shows you a little bit when you talk here about the blind zones in your car. If you look at the new ads of Nissan, for example, it has brake helpers, cameras, things that will help you reduce safety. But still, we have problems with fatalities. And in chapter 1 of the textbook gives you some kind of history about what happened. Uh, we talked about this in transportation. We talked about how many people die every single year just out of crashes every year in the US only. I'm not talking internationally, because we have other countries that have even worse numbers when crashes is a huge thing. Uh, in the 70s, when people loved their cars and travel was huge, we had almost 50,000 people. That was the peak, actually, 55,000 people dying every single year from crashes. This number went down, especially when I was telling you about the issues with improvements in the car that reduced the number of crashes. So right now we have an average about 30 to 35,000 crashes every, no, not talking here crashes, I'm talking here people dying. Crashes that cause facilities, people dying in the cars every single year. Uh, One thing I want to note here, we're going to talk about this when we talk about safety in this class. When we try to relate crashes, do we relate it to the number of people? Do we relate it to the number of cars? What do we relate it to? Do we relate it to traffic? How many vehicles on the road? We actually relate it to something called VMT. Vehicles, miles, travel. Have some we're gonna have some analysis. We're gonna solve some questions about how to calculate vehicles, miles traveled on the road. VMT is the best way to give an idea how many crashes are you improving or it's getting worse. VMT, we have, it's a huge number, I know. We have now in the US around 3 trillion VMT traveled every single year. I think, guys, with the pandemic, this number was reduced in 2020, but this is like the average number every year we have. 3 trillion miles traveled for every single vehicle in the US. That's the number here. And we try to reduce the number of crashes or accidents that happen during this travel. We have around 1.03 crash per 100,000 VMT. So for every 100,000 miles traveled by all vehicles, we have almost 1.03 crashes. This number went up to 13 in the last few years. And really, the research talks about why did this increase, even though we had more technologies in the car. Well, one thing that was related to this is something that we call here distraction. Distraction now is a big, big thing. We were able with some kind of ads and more, you can say, awareness given to people and police. We were able to reduce the amount of crashes caused by drunk drivers uh, by giving more DUIs, revoking licenses, and this reduced the crashes and fatalities ridiculously. And that was a great move. But another thing happened with the invention of cell phones. Even though we have Bluetooth in the car, people still text and drive, and this causes distraction. Also, your car now is more like a computer with screens. Just go into one Tesla, you can see this big tablet in front of you. So people are distracted. They remove their eyes of the road to go to the car technology, push on buttons, and this can cause some crashes. And now people want to do this really important text or just post a picture. Some people post their Facebook status of pictures or Instagram things on while they're driving, taking a picture, taking a selfie while driving. So this increased the number of crashes, unfortunately. Still trying as a researcher to figure out how can we do that. By the way, guys, my master's degree, that was in 2002, it's an old one, was about distraction in driving. Cell phones was just beginning to become a trend, and people had also GPS. We call it by then navigational systems was also a new thing by then, and now it's more people now use their phones also to find directions, more distraction. And the research was simple. How can this improve or deteriorate your crashes on the road and cause more distraction? So these are some statistics. You're going to find this, it's called GHSP. It's part of the DOT and analysis that they have posted online every single year. And there's a report that is being approved by the government of what they did and what are the traffic engineering, you can say, improvements that was done on the roads to improve this number and reduce the number of cities. Notice also next to that, DUI. You can notice here when I compare the DUI to 2014, it really went down. So with some awareness, people tend now to get drunk and drive less because they know they can cause trouble. This is also some, you can say, snapshots from the report of 2019. It shows here some of the traffic analysis. You can see here, what I'm putting this because we're going to talk a lot here in this class about traffic safety, because I want some of you to be traffic safety engineers. Again, it's a very good, rewarding job in terms of money, and also it helps save lives, and that's an amazing thing. When you save life as an engineer, that's beautiful. So it tells some, you can see it's just a little bit of statistics. What are the fatalities by different types of vehicles? How many people use seat belts percentage? Injuries as well. So When we talk about crashes, crashes have three types of crashes. When we talk about severity, how severe the crash is, we have fatalities. Sorry, this laptop is driving me crazy. We talk about fatalities, and this is how many people die out of having a crash. We have injuries, and we have PD, public damage, or personal car damage. So when you have just car that could go totaled, or you have a crash that caused problems to your car, then this is what we call here damage of your car. So we have three types of severity for crashes, and we want to reduce every one of these. But this is the most important for us. We don't want people to die or get injured badly because of a crash. Okay, guys, so you can see here some statistics, bicycles, pedestrians, how many people crashed, how many single car crashed, what types of crashes, how can we use that as designers and traffic engineers. This is people who have my GIS class will be relating to this very, very soon. We always have maps showing us where are the hotspots. And this is one thing also as traffic engineer. We have maps and we figure out where is a hotspot. Hotspot means that we have repetitive crashes that happened or severe crashes that caused some injury or fatalities. So this is a hotspot here. How can we improve this hotspot? Let's go there. And we send some analysis, people who do analysis or analysts, including a traffic engineer, and we do some kind of an audit, and this is what we call here a traffic safety audit. We go to this guy here, this place, figure out what went wrong. And auditors, traffic or safety auditors, don't have to be engineers. There might be different people from different backgrounds, but it's always traffic engineers who are the ones who do these audits. Traffic auditors also people who make great money because they go to these hotspots and they figure out how many problems or how much problems we have on these hotspots. And these hotspots come from data, from older data. We have a repetitive crash on these red hotspots. How can we improve that? And how can we reduce the number of crashes there? Figure out what went wrong in the design, what's wrong in the, we need more lighting. Do we need to reduce the speed? What's wrong there? And this is what we call here hotspots. And it's a really, really interesting thing, easy for us to do as well with the use of the computer and GIS. People who have the GIS, they use now mapping and data, and they create these maps and they now create these hotspots. Okay, chapter 1, guys, talks a lot about the history of traffic engineering. Since the invention of the first Ford car in the early 1900s, well, we had cars on the roads, even though we had some crashes with horses and donkeys before, but with the invention of cars created, we have now problems of traffic. People have different routes, they drive bad, or the design is bad. So here came your work as a traffic engineer. However, traffic engineering didn't start from only this. It started actually from early times of the Roman Empire, since they started building roads for their carriages and horses. Still, we needed some kind of a way to operate traffic on the road. And here came us as traffic engineers. And that's why you are civil engineers and traffic engineers. Some people will ask me, well, why do we do this? We are traffic engineers. Traffic engineers deal with lots of communication, some control. So why do not electrical engineers do it? Well, we deal with cars. Why do not mechanical engineers do that? Well, because it's always related to road building. Then we are also civil engineers. So sometimes we say, well, I can work with an electrical engineer. He's going to do the traffic light. And here comes a traffic light here. That's something really completely in control, some communication, some electrical engineer guy would work on it. but we still operate that because it's related to transportation, it's related to building the road, but still we do is this as civil engineers. And also chapter one talks about this briefly about how did we end up to become both civil who build stuff and traffic engineers who control and manage stuff. So the objectives for you, we talked about this. I'm just going to go very fast. We want something that's very fast, and that's your objective as an engineer now. That has a comfort. You want to ride your Uber, or you want to ride your car, listen to your music, have fun, or ride the bus and have some good seat. We want convenient. We don't want to wait in the station for 20 minutes just to take the bus in the cold or hot weather. We want to be convenient, and we want to be cheap. We want to pay a fortune for the bus, or you want to pay fortune for gas, or pay fortune to go for more for insurance or whatever. So here you want to be economical. I want to save fortune. You as the user and also the city or the state to pay tons of money. Again, we can make all the roads with lanes. We can pave 200 lanes every direction if the traffic was really bad, but that's not economical. And minimum negative environmental comparability. So that's your objective. You want to solve the problem. And this is solved by the word congestion. Talking about congestion, I want to compare here your work to Dr. Dickman's work. When we have a river and we have flooding, or when we have more water than this river or this pipe can handle, the pipe will blast if it doesn't work well, or the river will overflow with some kind of flooding. Well, we have the same issue because we have our channel here is the roadway. And instead of water, sometimes we deal with cars as water. I'm going to talk about this in a few weeks. So cars here are similar to the water molecules. We don't have this problem of overflowing like we have in flooding when Dr. Dickman teaches you that in his classes. We have another problem. This problem is called congestion. So congestion here meaning that we're going to have an endless number of cars going back. We have problem of people getting delayed, frustrated, and you name it. We problems that are related to that. So here it's a problem, and this here shows you the volume of vehicles and travel times. You can see here that we have an exponential problem of delay. The time goes up once the traffic goes really bad and we have more cars than the road can handle. So here we have problem of congestion and delay. In our traffic class, we'll be dealing a lot with the word delay. When we design any facility, traffic light, we want to reduce the delays for everyone here. And this is the delay here gives us the way to design, for example, a traffic light or a stop sign. We want to reduce the amount of delay. Delay is simply difference between travel time and travel time. Travel time when you're doing it today, travel time in the actual, and the travel time is optimal. What's that? What's actually optimal? Optimal is like you want to go from school to home or from home to school. It takes you 10 minutes, but you actually had 20 minutes. Your delay is 20 minus 10 is 10 minutes. So this is the delay we want to reduce for everyone. They will do lots of that in this class. So we have different solutions for congestion. Now we're talking here traffic engineers. Again, sometimes we think outside the box. So one thing is to build more roads. Now people, especially in bigger cities, tend to do less of that. It's so expensive. We don't have enough space for that. So we try to find other things. We want to put more supply in other ways. And we'll talk here about public transportation. So we want to, number one, to increase the supply. If you remember in transportation, we talked about supply and demand. Another way to think outside the box as transportation and traffic engineers is to reduce the demand. How can we reduce demand? We do apply something called road pricing. Road pricing here is a way to reduce the amount of people traveling, especially when you go to downtown or take your cars going downtown by applying more expensive parking. uh, Congestion is ridiculous there. So if we have more money applied to downtown areas, we call this congestion or road pricing. Instead of road, some people call it congestion pricing. So we try to reduce the demand on vehicles, private vehicles in the downtown area, and at the same time give them more supply, other ways of supply. For example, take your car away, take the bus, take the subway, and then you can go much, much cheaper. Another way, there are different ways now to do less demand. For example, we can have staggered working hours. Instead of everybody working from 9 to 5, let's enforce some kind of different ways to make people uh, take their cars and drive from 9 to 5. Let's have evening hours. Let's have midday hours. So we have different ways to do less demand. There are tons of ways to do. Carpooling is one way to do less demand. When I say demand here, demand for a vehicle. Instead of one person in the car, we can have 4 people in the car. One way to reduce the demand is what I'm doing right now, having a way to communicate with you guys in a different way. So instead of me and you driving to class, for a thing that can be done online, sometimes now online work is a way to reduce the demand for travel. Even though meeting face to face is more important and it's more practical, but sometimes it would reduce the demand in bigger cities. And then this comes here. This is a huge topic in traffic, something called ITS. We're going to have one class in the end of the semester. So it's going to be easy to do for me also over Zoom, since the end of the semester will be all over Zoom. Something called ITS, Intelligent Transportation Systems, ITS. How can we use technologies to give some information to the drivers and also give information to the planners to manage and improve traffic, give people some different routes. For example, if we have a crash here, how can we make this guy know that there's a crash and find a different way to reduce the congestion in your way? And now I was talking with some of my students about some of the ideas in traffic lights. How can we make these traffic lights more smarter? Talk with each other to reduce the amount of delay of everyone approaching this intersection here by giving green to bus first ahead of time, so nobody will be stopped. And you can see some of these ITS when you go to a traffic light, when the traffic light can see you and give you green only for you. So these are some of the ITS. And also you can see this when you go to the website of the 511, if I'm not wrong, the 511, to know where is crashes on which road, so you can reduce the problems of going to this area and get stuck there. There are different now applications using your phone. For example, some applications, even some your Google map, sometimes tell you there's a crash. So this is one part of the ITS research that we do. So let's now talk here. So as traffic engineer, the unique characteristic and responsibility of traffic engineers, number one, you need to provide safety. You need to work with people to reduce your congestion. You need to provide a some kind of convenience and also a an easy and fast and cheap. So here you want here economical and environmentally friendly, and this is part of your challenges as a traffic engineer. So what we're gonna be, I'm gonna stop here, guys, and we will continue just finishing this on Monday, and we're gonna be finishing chapter 1. So here we're gonna talk about, we did this in highway, the mobility and accessibility. So I'm gonna finish this, and I want you now over the weekend and also over for the next. I want you to start reading chapter 1. And I'm going to give you also some sections from chapter 2 to read. And again, Monday, as I promised you guys, it will be just some kind of a review of what we'll be doing throughout the week. We're going to meet on Wednesday, face-to-face, so in class Wednesday, where I'm going to solve some questions about, it's going to be easy because we did this in transportation, just a review of some of the factors of the driver. And so it's going to be, this will be our we were almost done with the introductory part, and I'm happy to do this. I know it's lots of talk. So guys, do you have any questions for me?
No.
Nicholas, any questions? Haley?
No, I don't have any questions.
I don't either.
Are you driving, Nicholas?
Yeah, I'm on my way to my next class.
Okay, so I'll let you go, guys, to get to your next class. I'm sorry about this. So see you, have a great weekend. See you Monday. And have a great weekend.
Thank you, you too.
Thank you, guys. Take care.